My name is Emil Gągała. I'm working at VMware Poland as a networking and security engineer. I'm not a programmer, so do not challenge me on some programming stuff. But I propose today's session about networking and security with Kubernetes, and just let's say to give you some overview of different types of networking with regular flat networks, Flannel, and with a solution prepared by VMware, which is based on an NSX. So that's a short introduction about myself. Just let's say for my understanding, could you let me know who has some networking background? Ah, okay, not so.
We're all using networks. So.
Okay. But yes, of course. I will talk as well about CNI implementation, but I'm cooperating with our developers from Palo Alto, and what I can see that my networking background and their understanding of network is a bit different. So let's build some kind of a bridging solution between both worlds. Okay, so let me start with like a traditional, I would say the easiest networking model with container. I will talk generally based on Kubernetes, but this as well applies to not only to Kubernetes but as well to other PaaS platform like for example OpenShift. So what you can see, this is like a regular I would say the basic setup. So when we are using the flat network for microservices for our pods. However, what is a challenge here? What you can see here in this picture, that here we don't have a right solution inside of the of this networking model for ramp in and out communication. So when I'm talking about some routing to external environment, some communication to external load balancer or firewall. So this is not part of the basic, or I would say plain implementation of Kubernetes networking. So idea, I'm from VMware. You know that this is company famous for virtual machine. So what we can see, and this is exactly based on as well feedback of my discussion with some customers, that as soon as it's a greenfield environment, that's relatively easy for them, let's say, to build something new and to start using cloud native application approach. However, if they have a legacy, and here legacy I mean either bare metal server or virtual machines, then they have a challenge how to, let's say, build some kind of a hybrid application, and how to extend this type of networking not only for like purely Kubernetes platform, but as well to regular environment when you can have a virtual machine or databases. This is an example of a real customer scenario. I've been recently to Sweden, and we have exactly this kind of talks when customer would like, okay, they start developing new application based on Kubernetes. However, immediately they recognize that they have some workloads on, let's say, legacy environments, on VMs and hardware, bare metal servers. So this was exactly the case, which is, let's say, not purely focus of Kubernetes, which is mainly, I would say, our purely this area. And by the way, can you see some, let's say, some similar challenges in your application or your use cases? How, let's say, how to build some common networking and security layer between like a new cloud native approach and legacy applications? Or you don't care about this?
Open country, for example?
Yeah. You know, when you look, but again, this is a very good point. By the way, I work previously for Juniper Network, so I know Contrail quite well as well. So, but again, there are some, let's say, other, I would say, additional solution, because this can be developed as a part of a CNI plugin, but this is not part of this basic networking with flat network or with Flannel. So I will come later into this. Okay, next is about microservices and microsegmentation for microservices. So here idea about or I would say, requirements for this type of communication, again, is to put some additional layer of security between pods. Again, this is maybe not so commonly required, and particularly by developers, because, for example, when I talk to my colleagues who are, let's say, even responsible for maybe not this kind of solution, but, for example, for our OpenStack distribution or for our cloud management platforms, they want to have a life as easy as possible. So from their perspective, of course, they don't want to have any kind of a security. However, this view, when we need to separate and to segregate and to isolate some pods, this is a strong requirement from security and networking administrator. So you know that there is like a trade-off between freedom of developers and I would say some compliance or some security regulation which are needed by security administration team. So that's let's say some next area and requirements how, let's say, from this fully distributed application, which is still fully distributed, but here we can provide some additional layer of security. So we can put some security layer directly into this application. Next area which I would like to address later, this is about the multi-tenancy. Again, this is just let's say question to you for my knowledge. If you are deploying your application in Kubernetes environments, do you use just one namespace or maybe a few, or you try to like create some isolation like one namespace per tenant or per application? So here I would like to get your feedback, because I know that there are some customers who are just use one, let's say, default namespace, and they put entire pods in this default namespace. But can you see some needs, or maybe you have already, let's say, more than one namespace in your projects?
Our clusters, Kubernetes clusters, have system namespace and default namespace. So we have at least two namespaces.
Yeah, but these are, let's say, yes. Oh, yes. But this was my question is: can you see, let's say, some requirements or some need for isolation, like a tenant separation?
Organizational isolation,
Mm-hmm.
we added a separate namespace called infra,
Mm-hmm.
of the elements that need the general infrastructure, and probably in the future a test namespace and two similar.
Yeah, so like a typical.
For general
Mm-hmm.
production, just into the default one, maybe add the network separation in the future, because it's separate from namespaces.
Mm-hmm. Okay, so who has, let's say, more? So this is exactly the case which I'll be talking about. So who has more than, let's say, more than default namespaces in your product? Okay.
Actually, in OpenShift, you get multiple namespaces. There are some, they call it projects,
Mm-hmm.
and there are some default ones for logging, for our management stuff, and also for my case, it was for production and development environments that were separated using namespaces.
Okay.
Actually, a valid.
Mm-hmm. Valid requirement. Yeah, that's what we see. Maybe not, let's say, in some smaller organization, in an organization which are just starting or trying. But later on, this can be like a typical requirement to separate like a development, testing, and production environment. And finally, let's say the next requirement, which I think needs to require some extension. This is mainly, again, for networking operational team. So they need to have a flexibility. Even today, I came from Katowice, from some customer POC, not directly related to Kubernetes yet, but when we talk with networking and security team, they were not only interested, let's say, on day one, so it means, okay, how to configure something, how to start something, but particular maintenance teams, the people who are responsible for this type of infrastructure, they more focus on day two. So they ask question, okay, what is a visibility? How we can monitor traffic? Can we perform some end-to-end troubleshooting? Can we have like a end-to-end path, trace flow? Can we get some net flow information? So this kind of requirements, which are, let's say, maybe typically from the developer perspective, this is a bit boring. But from the people who are responsible for administration, I would say this is critical for daily life, in particular if something can go wrong. Okay, so this is a quick refresher, I would say. So I'm not going to explain this into more details, but the most important here to recall some information about networking with Kubernetes, that the IP address, which is visible in externally, is allocated to single pod, not like a single container. And by the way, this is I would say change in networking approach, which is a bit different in Kubernetes than it used to be in Docker, when any kind of, let's say, communication to external environment requires mapping of ports. This is, I would say, much more familiar to people who used to work, for example, with virtual machines, because from their perspective, this pod level, and this is again some feedback from customer, that the entity of pod, it is much easier to, let's say, understand and let's say start working with this, because they are treating this just, let's say, like a maybe not a small virtual machine, but like a operating system with some internal process communication, and just, let's say, one IP which is visible outside. However, if you look at the bigger picture, so this here we have a bigger scope, and this will be as well some kind of topology which I will use for a lab. So I have some labs which I will demonstrate working with Kubernetes networking, in particular with our own solution. So here you can see like two nodes. Again, if I would like to get as well something for myself, if you are running nodes, are you running this typically on? Okay. Are you running this typically on bare metal server or rather as VMs? I'm not talking about like a VMware VMs, but any kind of VMs. So if you are talking about node, this is for in your project. This is more like a bare metal server or rather like a virtual machine to get some, let's say, flexibility and some possibility, for example, to allocate resources more dynamically than just, let's say, bare metal server. What is your approach when you deploy like Kubernetes node? VM? Okay, good. Mm-hmm. So this is exactly the same approach which we took. By the way, the solution which I'll present works both on the KVM and SXI, so our NSX. So we think that still like a majority, and you confirmed this just now, that majority of deployments will, let's say, still utilize virtual machine as a node. And inside of this we have our pods. And here you can see some, let's say, different namespaces, and here you can see exactly some of the first challenges, because what you can see here that we have, let's say, IP network which is allocated to like a single node. So here is this 10.10.10/24. Here is 10.10.20/24. However, you can see that border between these two nodes is not in line with the border between namespaces. So you can see that here there is, let's say, some challenge, at least some routing challenge or separational challenge. Then when you have the two pods which belongs to the same namespace, but they are from different IP subnets. So this is not, let's say, something what networking people like. This is not this kind of a separation, because typically they prefer to allocate and to treat namespace like in similar way like a routing instance or VRF. And that's let's say one thing, but the other is that in this environment we have to interact directly with physical network. So this is like with the base approach when we would like to use flat network. So this is again something which By the way, does any of you use, let's say basic approach with flat network? I'm not talking about Flannel yet, just like a flat network. So exactly here, when you have these pod networks visible inside of the physical network. Yeah, this is I would say this is nightmare of a networking administrator, and probably for anybody who would like to have a flexibility when deploying this network. You don't need to communicate. You don't need to communicate with networking people. Okay. Quick review of different services. So first, you can see that this presentation, this is built like requirements by requirements. So I presented some requirements about, for example, tenant isolation, about how we can perform namespaces. Here, next requirements is, let's say, about how we could solve load balancing, east-west load balancing with Kubernetes service. So again, this is something which I'm going to address later on. Next service is about ingress load balancing. So previous one was about east-west load balancing, like internal between different pods. Here we would like to implement the service which will be for ingress load balancing, so for the traffic coming from external network. So as you are familiar with this approach, this is not part of Kubernetes networking. So this is, I would say, out of scope. But again, you have to have a communication, you have to have a external communication, and you can use either a F5 load balancer or maybe a HA proxy, but still this needs to be incorporated into entire application environment from networking perspective. Okay, let's go back to next requirement or next functionality. This is namespace. We already talked about this, about possibility to logically separate, and to build multi-tenancy with different namespace. Not only from the perspective of networking, but as well maybe some authentication, some role-based access control, or providing some dedicated resources. Okay, so let's look with what option we have. Like, let me first focus on a regular approach with flat network and Flannel, and then I will jump into our own solution based on NSXT. So again, so here we have an assumption that we are using flat root network topology. What does it mean? It means that here we have this IP subnet assigned to particular node. So to any pods which we run in this node, they will use the IP addresses from the subnet 10.24.2, and on the other node, this is subnet 10.24.1. And if we don't have any kind of overlay networking, so this is like that's the reason why it's called like a flat routing topology. It means that any kind of a communication which is between these two pods, so if they need to communicate between each other, we have to announce this routing information about these two networks, this 24.1 and 24.2. We have to announce this routing information into physical network. And again, here there is one comment, one very valid comment. I already mentioned about this, that namespace has different boundaries than not IP subnets. So we have like a mismatch between the IP subnet, which is allocated to entire Kubernetes node, and here we can have situation that, for example, this pod will belong to one namespace, and the other two they will be in the other namespace. So there is no like a clear networking separation, and you can see that we have some mismatch between the logical separation, which is created by namespace, and networking separation, which is a bit different, because this is not implemented on the level of namespace, but rather on the level of node. So that's the reason why probably this is, let's say, not so popular use case. And Next case is with introduction of overlay networking. So this is exactly how, let's say, Flannel implement this with this etcd key value store. And here, what is a difference? So first of all, with Flannel, and by the way, again, question to what kind of a networking mechanism or networking technology are you using when in your Kubernetes projects? Is it just a Flannel, or maybe WIF, or maybe Calico, or because I know that, you know, if you look at, for example, CNI web page, this is container networking interface, then you will see that there are like dozens of different kind of implementation. As far as I know, the most popular is Flannel, but again, I would like to hear your feedback. So who uses Flannel in terms of networking? Not so popular. So what you are using? WIF, Calico, and
Or simply flat.
simply flat. So the previous one. Okay, interesting.
Or maybe or flat with Calico for enforcement of network capacity, but not routing.
And you mentioned as well open country. Do you have some experience, or just, let's say, theoretical one?
Let's say deep in the guts of open country. But I don't run it, and I prefer not.
Yeah, not with Kubernetes.
Okay, yeah. Yeah, let's say entire area of networking with Kubernetes is, I would say, quite young, and there are many solutions, and I would say that there are too many solutions, and we'll see which one won. I thought that the Flannel is the most popular because it was, let's say, well recognized. It was developed by CoreOS. And the idea, but again, not only Flannel, but with as well and Open vSwitch networking, the idea is to use overlay tunnel. What does it mean? It means that we are tunneling, so no longer these subnets which are allocated to these pods, like this 10.24.2 or 10.24.1, no longer this is visible inside of a physical network. Why? Because here you can see this green path. This is a tunnel. So typically, if you are talking about the Flannel, there are, let's say, different encapsulation methods. One of most frequently used is based on the VXLAN technology. So in that way, we are just tunneling. So we are encapsulating traffic from these IP addresses in a tunnel, in a VXLAN tunnel. Again, nice. At least we solve one issue. There is no container network visible inside of physical network. So we make networking infrastructure guys very happy about this. But again, still the, let's say, challenge is how, let's say, to solve communication with external. So how to, let's say, add NAT, how to integrate this with routing or with external load balancer. Of course, it can be done, but this is not something which Flannel addresses, because Flannel focuses on again, CNI networking or container networking. So this was short introduction to this topic, and I would like to quickly jump to, let's say, our approach and how we implemented CNI plugin for containers. Again, this is for Kubernetes. So what I'm talking now is NSX. NSX is a software-defined networking solution from VMware. This is not only for regular virtual machines, but recently, with the recent release, we as well added support for Kubernetes networking. So implementation of CNI plugin. So in our approach, and here maybe some information. So our approach exactly addresses routings, because we have so all what you can see here. This is like a sample networking topology with two types of routers. So this is a software implementation. So this is SDN networking, software-defined networking, and we have like a provider router when we provide the communication to external environment via, for example, via BGP, and isolation, like a tenant isolation for namespace, we solve with creation of dedicated router. So here you can see like a two-tier hierarchy of routing. So this is here it's like tier 0 router and tier 1 router. So this is provider router, and this is tenant namespace specific router. So what idea is that for each namespace which we create, we allocate dedicated tenant router and dedicated logical space. And again, you will see, let's say, this much better with more details. For each pod, we add implementation of distributed firewall. So that's the idea. So, and again, some information related to visibility and troubleshooting. So possibility to, for example, perform trace flow or path or port connection. So to see how the traffic flows exactly via entire networking infrastructure from one pod to the other pod. Let me go into some details. So this is idea of our plugin. So currently this plugin is prepared for Kubernetes and for OpenShift. Later on we can consider like adding support for other types of container networking. We'll see, maybe Mesos, maybe libnetwork. So that's the idea that our NSX container plugin just, let's say, watches events on Kubernetes API server, and then talks directly to NSX manager. So let's see, like a first task. Let's imagine that we are start creation of a new namespace. So we have already one namespace, like for one tenant. We have already created some infrastructure router, so this will be a responsibility of networking admin. And what we are doing here, we are creating new namespace. So what our plugin does, it watches for events about creation of a new namespace. So it watches API, Kubernetes API server. Then when user creates new namespace, then we are catching this information, and based on this information, we send a request to our NSX solution to create new instance dedicated for new instance of router and logical switch dedicated to this new namespace. So this is exactly how it works. So based on the observation, based on watching of Kubernetes namespace creation event, we are able to put and to instantiate tier dedicated tenant router and the dedicated logical space. This is my lab environment, and the next slide I will switch to demo. So you will observe that we are creating this new namespace, how it looks like from the perspective of Kubernetes, and how it's visible inside of NSX. Okay, so this is my lab environment. Okay, so here is initial configuration. It's difficult. As you can see here, this is exactly the setup which you could see in the picture, in the drawing which I showed just before. So we have a single master and two nodes, and this is a starting topology. This is a starting topology, and let's see how we create namespace and what happens in the background. Okay. So this is like a current status. So these are namespaces which are like default one, the one which you mentioned, and we would like to start our new project and maybe create new namespace. So the namespace which we will create, it's called the NSX UJob. By the way, this was the name used internally by our developers. Do you know what does it mean? they were very funny, and they found that this is in Esperanto, this is container. So that's how they decided to use this name. Okay. Okay, and this is there are let's say additional setting as well that we would like, let's say, to specify some metadata information and use this as a no-nut namespace. Okay. So let us see what happens in the background. So this is console of NSX, and when you see here, we have some, let's say, information about routing, switching, and firewalling. But let me start with the routing information, or maybe with a switching one. Okay. Yeah, finally we have it. There, I can see that there is some latency. So as you can see here we have namespaces, the namespace which we created. This is exactly mapped. So so you can see that here we have this namespace NSX usual, and it has its equivalent inside of NSX. So what we did, we just create logical switch. This is overlay type of networking, and currently you can see that this is attached to only single port, and this port is attached to logical router. Logical router, which was created particularly for purpose of this namespace. So you can see that we have an instance of dedicated router. So currently what we did, again, let me come back to this demo slide. So what we did, we create additional router, tier 1 instance. This is already auto-plumbed to provide the router. Because we specified that there is no NAT, so currently we are not using any NAT configuration here. And we allocated to this namespace, we allocated some IP address block. So this is like a preparation of networking infrastructure. So this was exactly what I demonstrated, and so we have already our namespace ready. Let me jump to next topic, and I would say that this is a clue of this solution. I know it's quite late, and maybe it's not good to provide, let's say, too many information, too many details. But what we did, this is, I would say, the most important to understand implementation of CNI plugin inside of NSX. So what we did here, so how this setup is built. This is like a node VM. So this is a Kubernetes virtual machine. It can be either on A6i or on KVM. Here, what we have, okay, you have this information. So this big one, this is a hypervisor. Then we have our virtual machine. And inside of this virtual machine, we put some additional instance of Open vSwitch. Why? Because we would like to create some, let's say, interfaces for this pod. So again, next part of my demo will be creation of dedicated of a new pod and connectivity of this pod to this network. So how we are doing this? There is inside of this Open vSwitch there is some internal VLAN trunk. So for each pod we create some internal VLANs. They are not visible outside of the virtual machine. However, this provides us possibility to attach each pod to specific instance, for example, of distributed firewall. So as you can see, with this approach, if there is a traffic between, let's say, these two pods or across pods on different nodes, we are able to enforce security for them. So what we are doing here, that communication from this pod to this pod will go via firewall. Again, this firewall is part of a hypervisor. So this is not something which is visible or can be changed by developer. So this is exactly something what is preferred by security administrator. They want to have still like a full control on what's going on inside of the container networking. So that's the way how we can, let's say, attach pods to security infrastructure which is implemented inside of a hypervisor. So let's look into some creation of some flow. Maybe I will draw this. So here, what we would like to do is to create the pod attachment. What does it mean? That we need to create some new logical port on this logical switch. How it's done? So again, again, very similar as in the event of creation of a namespace. Here we are watching for the creation of new pods. So when a new pod is creation, then there is a notification to our CNI plugin, and this CNI plugin creates, first of all, request IP address from subnets which was allocated to this specific namespace. We are performing mapping between a MAC and MAC allocated to the IP address and for this logical switch, and again assign a VLAN to this specific pod. So you could see that here on this previous drawing there is a dedicated internal VLAN. So this is something which is implemented behind of the scene. And then finally, when a new pod is available, we are performing this kind of a connectivity. So we are attaching via this internal VLAN, via Open vSwitch, we are attaching new pod directly. We are creating CIF interface, and this is now attached directly to a hypervisor. So this is the way how we are encoding new pods to infrastructure, to networking infrastructure, which is implemented inside of a hypervisor. And this will be part of my next demo. So here in this demo, so in previous we created new namespace with dedicated router, with dedicated subnet, with dedicated logical switch. And now we will attach new pods into this namespace. Okay, so you can see here that currently for this switch we have only single for this usual switch we have only single port. So currently this subnet is just attached to router which is dedicated for this namespace. We don't have yet any pods. So now we set our context to the namespace which we created. And this is really like this magic when you present a demo, because entering this manually, this would be very, very, very difficult. So having like a script for this demo is much easier, particularly for demonstration. So this is YAML file of the pod which we'll create. So this will be it will consist of four pods, and it will just enable some basic web service. So let's create it. Okay, here there is no labels in this YAML file. In last demo, I will show you how we are attaching labels, and then we can enforce some security using these labels. Okay, so it was created. Let's see if it's done. Okay, we are lucky. Okay, so what should happen here? Then we should see now that we have attached new ports So let me go back to NSX console and refresh this information. Okay. By the way, the version of NSX which I'm showing here is beta 1, so this will be shortly available even this month. We should wait a bit to have a green status here. This will come, believe me. But you can already see that we have some ports created. So these ports are just attachment of these ports to logical switch. So that's the way how it's configured. Okay, and you can see that. By the way, maybe I didn't mention this, but this logical switch, this namespace, it's not. Of course, this is not only for a single node, but it spans our entire Kubernetes cluster. So any kind of implementation, we, from our perspective, we don't care where each pod is implemented. So some of them will be on the first node, some of them will be on the second node. We don't care. So this pod is created on the other node. Okay, let me refresh. Finally, you can see that that's up. So so now we have our setup is already connected. So what you can see here, what we did here. What we did here, just again, we attached these new pods, these 4 new pods, to our namespace. Okay, so this was just about basic connectivity. Let's look about next service. This is about east-west load balancing. So here we would like to create some replica and to load balance traffic across multiple pods. In our implementation, we are not using like a regular Kubernetes kube proxy. We are using our own instance of kube proxy. So again, next demo will be about service creation. And so let me switch again to this demo part, and let's create some services. Okay, so here we have a demo service, application NSX demo. So what we are doing step by step, the final result that will achieve our application up and running with both like internal services and as well external load balancers. Okay. So this internal load balancing is implemented by NSX kube proxy. Let's see some more information about this, and you can see that IP address which is allocated like to entire replica set, and here we have dedicated on endpoints. So these are exactly IP addresses from namespace allocated to this namespace user. Okay, and we can see that how, let's say, this traffic is load balanced internally. Let me see. Let me show you that. Here you will see number of group is 4, so the number of our pods in replica. Okay, and information about groups, and here you can see exactly that how flows inside of Open vSwitch are present for these different IP addresses assigned to these four pods. So this is how we are building this connection track table inside of Open vSwitch. Okay, we can extend this into 6 replica. Let's see. Okay, this is already up and running. And of course, we'll see that this we can see that there are 3 IP addresses allocated plus 3 more. It means that our set is now consists of 6 pods. Okay, maybe okay. I will again, and you can see that now it's load balanced. That internally this traffic is load balanced across 6 pods. Okay. And management pod, just let's say to get connectivity into this. Okay, running. Just to verify connectivity. Maybe I will exit from this and show you that currently, again, we increase number of these ports connected. Okay, you can see that now we have like 6 plus 1, so we have 6 pods of web service and 1 dedicated for management. Still, our application doesn't work yet. It's not yet available because why? We don't have yet external connectivity. So this will be next part of creation of our application. So what we need to have an external load balancer just to have our application up and running. So currently what we did, we have already these pods created as a replica set. We have this and what we need, we'll use here Nginx for load balancing of traffic from external environment. Okay, very short demo there, and then we'll jump into security, which will be last part of my demo. Okay, so let's go back. Okay, so we are using for external load balancing, we are using Nginx. And this traffic will be available on both HTTP and HTTPS ports. However, what we need to perform, here we have definition of this ingress service, ingress load balancing, and let's create it. Okay, gets status. Okay, this is up and running now. So our application should be available now. So as you can see, this application now is available, and when we refresh this, that it's load balanced across all our pods. So this is something what you can see that this IP address changes. So that's the way how we created entire application. And of course, it's available. You can see that it's already available. Okay, so finally, as a last part of this demo, let's add some security. So maybe before adding security, here as a part of this application, you can see that there is port scan available. What was the IP address? Okay. So now this will last, but you can see that currently there is no any security protection. So if somebody has access to internal infrastructure to these pods, then it is possible. Let's wait when we see here the IP address 130. You will see that these ports will be open. Let's leave it open. Let me continue with the next part, and with next part we will just secure this this application. Okay, so last part is about adding security layer. So there are like two possibilities currently in Kubernetes. So one is to use Kubernetes network policy. This was introduced quite recently. This is quite fresh feature of Kubernetes. However, this is already something which is implemented. And the second one, which I will demonstrate, this is using of some predefined labels. So in our YAM specification, we'll put some labels to assign some label to pods, and then based on this label, we'll enforce some security rules. Why? This is very simple demonstration. This is just, let's say, to demonstrate that we can stop a port scan. However, when you can see, when you can imagine, this can be applied to any kind of more sophisticated environment. Okay. So this will be last part. Okay, it's still going. Let's wait a bit. Maybe I should push a smaller subnet. But so this is currently this is without security. I'm waiting for port 130 for IP address 130. So currently, as you can see here, these ports are open. So being part of the internal environment, it is possible to easily access it. And this is something where maybe shouldn't be available from any like management port. It should be available only via ingress load balancing. So let me present what we are doing to secure this. So I have a few demos prepared. So how it's security built within this setup? Okay, so here we have information about current application. You can see that this is a management pod. So this is exactly the pod when we issue a port scan. And we have six web services running. Let's delete it, and we'll create this from the scratch, and we'll add security to the new environment. Okay. Terminating. Let's wait a bit. Come on. Okay. Great. So here you can see how we are here in this exercise, in this example, how we enforce security. This is based on the labeling mechanism. So this label, which is here, one is as a name of application, which is NSX demo. And second is a security group web tier. This security group will be mapped exactly to NSX distributed firewall rules. So based on this security group label, which is called web tier, we'll assign some dedicated security policy inside of NSX. So that's how we are binding the security policy between pod definition and NSX. Okay. Let's see. Okay, so this is already running.
You have to restart containers to apply this security rule?
To update this security, I think so, yes. Okay. Get all. So our service is available, and let's see. Maybe without scan, because we'll jump into scan just in a moment. Okay, so this is application again running across these three pods. But what happened in the background? How it's implemented? So let me refresh this because this is an old configuration. So you can see that there are four logical ports which are mapped exactly to the web service which we created. However, what I would like to present you that here we have like a three tags. And one of these tags is exactly the label which we use in the YAML definition. So you remember that one was application, which was the value was NSX tag, and the next one related to security is web tier. And based on this security tag, what we are performing here, there is some basic firewall rule. You can see here that we have some simple rule which says any traffic from one web pod to the other web pod will be dropped. And how it's implemented, how this group is created. This is not yet refreshed, but I will show you the group definition. So membership, okay. Membership for this security group is called any tag which equals to web tier. So this is exactly tag or which was specified as a label in the pod definition. And as you can see, this is okay. Maybe let's go to overview. We have already 4 logical ports as a member. These 4 logical ports, these are exactly these demo pods. And now when we perform the scan, maybe let's put a smaller subnet. You can see that all these ports, they are not available. The ports which are here presented, these are only from this management pod. So any other pod, we can stop this. You can see that are not visible. So this traffic, you could see that here is address 132, 133. They were not visible inside of the port scan. So why? Because security is enforced by this security rule. So this was just the idea how we are applying the labeling to enforce security policy. Okay, so this was last demo, and exactly summary. Any question? So
I think we have time for 2 questions.
I'm sorry for let's say taking maybe too long. I hope that I know that it's too late, but I hope that at least you got idea of this implementation. So any questions?
2 questions. But very quick. Can I use it on AWS, and why is it so expensive?
Okay. This is a very good question. Exactly the same question which I got from customer in Sweden. I would say that not yet, but this is something which is coming, because what we can see currently, this is available on premises. So for customer who owns hypervisor like AVM or A6i, AWS version will come, because this is I would say very commonly requested. This is something what we already started working, and why it's so expensive. I don't think so. It's so expensive.
I don't know.
Yeah, neither me. Yeah, I know that. I know that VMware is expensive, but let's not talk about money tonight. Okay. So, thank you.